All right, so tonight we're diving into something that might just keep you up. We're talking AI coding assistants, the kind that help write code. And there's this brand new attack straight out of a cybersecurity nightmare. We've got this research paper here that it details how this whole thing works.
It's a fascinating paper for sure. These attacks target um, Code LLMs, so large language models, but specifically the ones that are designed for understanding and generating code. Like you've got Codex, Code LLM, CodeGeex. Think of it as well, like having an AI partner, one that can write code with you, and in multiple languages too.
And they're not just like some niche thing anymore, right?
Yeah.
GitHub Copilot, it's like becoming pretty mainstream. And I think CodeGeex already has something like over 500,000 installations on just VS Code alone.
Yeah, you're exactly right. That's exactly what makes them so attractive to attackers. I mean, the potential for damage is it's huge, if they can figure out how to exploit these tools. And this paper, it reveals a whole new level of vulnerability. It really does.
So then what's the weak point? How are these attacks even possible?
Well, the key here, it lies in how these code LLMs interact with external code. You see, they're constantly pulling in code from all these different sources, like open source platforms, such as GitHub, copying, little snippets, installing packages. It's all part of the process. But that's where the attacker, that's where they can slip in something malicious.
So are we talking like injecting a virus into a code library or something?
It's actually more insidious than that. Previous attacks on code LLMs, they all had limitations. You had
Yeah.
backdoor attacks where someone would tamper with the training data, embedding malicious code that's, designed to trigger when the AI encounters a specific prompt. It's like a hidden time bomb.
But if the training data is coming from a trusted source, how would how would an attacker even get access to it in the first place?
That's the challenge with backdoor attacks. You're right. The attacker needs, they need control over the training process, which is pretty unlikely in most real world scenarios.
Okay, so backdoor attacks are probably not the biggest concern then. What else is out there?
Well, there are also adversarial attacks. These involve crafting malicious input code that essentially, confuses the LLM, causing it to generate faulty code.
It's more of a disruption than a targeted
Yeah,
attack.
exactly. Adversarial attacks, they can reduce the quality of the generated code, but they lack the precision to achieve, specific malicious goals. They're more like, uh, I guess you could say they're like throwing a wrench into the gears.
So that brings us back to TPIA,
Mhm.
and from what I'm gathering, it's a whole different beast. It sounds like it combines the targeted nature of backdoor attacks, but with the ability to completely bypass the training process.
You hit the nail on the head there. TPIA, it leverages the way LLMs use external code, and introduces a tiny, almost imperceptible modification. Think something as small as a comment.
Hold on, a comment.
Yeah.
But those are just notes for human developers, right? The AI should just ignore those.
Right. And that's exactly what makes TPIA so stealthy. Think about it. Most security tools, they're looking for malicious functional code, lines of code designed to execute a harmful action. But TPIA's modifications, they're non-functional. They're like whispers in the margins, and they just slip right past conventional security measures.
Okay, I'm intrigued. But how does this whisper, how does it actually turn into an attack?
Well, so when the victim, using their AI coding assistant, encounters this seemingly harmless comment in external code, well, the LLM, it interprets it as a hidden instruction, and this triggers the AI to generate malicious code, and it's placed precisely where the attacker wants it within the victim's project. It's like planting a seed that blossoms into a security nightmare.
So a comment acts as like a set of secret instructions for the AI. I have to admit this is pretty ingenious. But can we get into like specifics? What would a real world example of this? What would it look
Yeah,
like?
sure. The researchers actually used several malicious objectives in their study, but let's take the weak encryption example. So imagine the attacker's goal is to force the victim's code to use a weak encryption mode called ECB, which is notoriously easy to crack.
Okay, so how do they pull that off using just a comment?
Well, it all starts with creating a task for the LLM. that mimics the victim's coding environment. So the attacker breaks this task down strategically. First, you've got conditional code, and that ensures the necessary packages are already present in the victim's code. In this case, it would be something related to encryption libraries. Then comes the position code, which acts like like GPS coordinates. It pinpoints the exact location within the victim's code where that malicious code should be inserted. And finally, there's the target code, which in this case would be, it would be the snippet that forces the use of the weak ECB encryption.
It's like setting the stage for a magic trick, but instead of pulling a rabbit out of a hat, they're slipping in malicious code.
A very apt analogy, yeah. Now, to complete the trick, the attacker needs to generate the malicious comment, what the researchers called the malicious perturbation. They actually they use the LLM's own parameters to do this.
Wait, they're using the AI to create the attack against itself. That's fascinating.
Exactly. It's a sophisticated process, involves a lot of mathematical optimization. But the bottom line is that the attacker is, they're leveraging the LLM's intelligence to craft a perturbation that is almost guaranteed to work. They're essentially, they're turning the AI's strengths into a weapon.
Okay, my head is spinning a bit. Let's step back for a second. We've talked about the theory, but how effective is this in practice? Did the researchers actually manage to pull off these TPIA attacks?
The results are, they're pretty alarming, to be honest. They tested TPIA on 3 different open source code LLMs, including CodeGemma and CodeGeex too, and they achieved success rates of up to 97.9%.
Wow, that's a staggering success rate. So this isn't just like a theoretical vulnerability. It's a real and present danger.
And it gets worse. They also tested TPIA on commercial applications like GitHub Copilot, and they still achieve success rates over 90%. That means that this attack can be used against the tools that developers are relying on right now.
And to think, all it takes is a tiny, seemingly harmless comment to potentially compromise an entire project. Yeah. This really highlights, the potential for damage.
Absolutely. What's even more concerning is that the researchers, they achieve these high success rates with perturbations as small as 8 tokens. That's incredibly small and incredibly difficult to detect.
This is starting to paint a pretty bleak picture. So the big question is,
yeah, can
we defend against this type of attack? What options do developers and users have?
Well, that's the million-dollar question, and unfortunately, there aren't any easy answers. The research paper, it doesn't offer concrete solutions, mainly because, TPIA is so novel, and unlike anything we've seen before, traditional security measures are simply not designed to deal with this level of subtlety.
Okay, so what are the main challenges when it comes to defending against TPIA? Where do we even begin?
One of the biggest hurdles is detection. As we discussed, traditional security tools, they're looking for malicious functional code, not these hidden non-functional perturbations. It's like trying to find a needle in a haystack, but the needle is, it's disguised as a piece of hay.
Right. That makes sense. But let's say we manage to find that needle. How do you remove it without potentially breaking the code or making it unreadable? It's like trying to perform surgery on a strand of DNA.
Exactly. Removing these perturbations safely and effectively is a huge challenge. The researchers, they tested some basic defense mechanisms, and they found them to be, ineffective against TPIA. It seems like we need a completely new approach to security when it comes to AI coding assistants.
It sounds like we're entering uncharted territory. This really is a wake-up call for anyone who uses AI coding tools. So where do we go from here? What can developers and users do to protect themselves in the meantime?
Well, for starters, we need to spread awareness about this threat. The more developers understand how TPIA works, the better they'll be at identifying potential vulnerabilities in their code.
So education is key.
Yeah.
But what about concrete actions? What practical steps can developers take right now?
Above all, it comes down to vigilance. Don't blindly copy and paste code from untrusted sources. Scrutinize those open source libraries and packages before integrating them into your projects. And it's not just about the success rate. It's that the researchers, they were able to achieve these attacks using remarkably small perturbations. I mean, sometimes as small as 8 tokens.
So we're not talking about inserting huge chunks of malicious code.
No, no, it's incredibly subtle. It makes it even harder to detect, with the existing tools. That's what makes TPIA so dangerous. It
Yeah.
completely flips the script on, well, on how we think about code security.
It's like a hacker whispering instructions to the AI, and nobody else can even hear them. So where do we go from here? I mean, if traditional security measures are falling short, how do we even begin to defend against something like this?
That's the question everyone's asking right now, and the solutions, well, they aren't straightforward. The research paper, it highlights the need for a fundamental shift in how we approach, AI code security. We're not just talking about patching a few holes. We're talking about, rethinking the entire security landscape.
Okay, so what are some potential starting points? What are the researchers suggesting we focus on?
Well, one of the key areas here is detection. We need tools that can recognize these non-functional perturbations. Those hidden instructions that trigger the malicious code generation. Traditional security tools are focused on identifying, active functional code, but TPIA it operates in a completely different way.
It's like teaching a security guard to spot a thief who's disguised as a janitor. They're looking for the wrong sign.
Precisely. We need to develop security tools that understand the nuances of how these code LLMs work, how they interpret and process information, even those, seemingly harmless comments.
So it's not just about like scanning for malicious code. It's about understanding the AI's thought process. It's potential blind spots.
Right. And even if we do develop effective detection methods, well, then there's the challenge of mitigation. How do you safely remove these perturbations without breaking the code or altering its functionality? It's a delicate process, especially
Okay.
when you're dealing with complex code bases.
It's like trying to remove a splinter without causing further damage. Are there any promising research avenues in this area?
Well, there's a lot of ongoing research that's focusing on building more robust code LLMs, models that are inherently less susceptible to these types of attacks. One approach is to limit the model's reliance on external code. You're reducing the potential attack surface.
So it's about creating a more controlled environment, one where the AI isn't as exposed to potentially malicious inputs.
Exactly. There's also research exploring, the integration of security features directly into the core architecture of these models. Think of it like building a security system right into the foundation of the house, rather than just adding, an alarm system after the fact.
So it's a two-pronged approach, developing more secure models and creating tools that can identify and neutralize these hidden threats in existing code. But this sounds like a massive undertaking.
It is, and it's going to require a collaborative effort. We need researchers, developers, and security professionals, to work together to share knowledge, expertise, and resources.
Like a global call to arms for the cybersecurity community. And as we move forward, what are some of the broader implications of this research? What does TPIA tell us about the future of AI security?
I think one of the biggest takeaways here is that AI security, it's not something we can afford to take lightly. We can't just assume that AI systems are secure by default. As AI becomes increasingly integrated into our lives, from writing code to generating art and music, well, we need to be proactive about anticipating potential vulnerabilities.
So TPIA is it's kind of a wake-up call,
Hmm.
reminding us that the security challenges of the AI era are, well, they're unlike anything we've faced before.
Exactly. We're entering uncharted territory, and we need to adapt our thinking accordingly. We need to be vigilant to constantly evolve our understanding of AI systems and the threats they face.
It's almost like we're entering a new arms race with the cybersecurity community constantly trying to stay one step ahead of those seeking to exploit AI.
In a way, yes. But it's also an opportunity to push the boundaries of AI security, to develop innovative solutions that protect us from these emerging threats. This research is it's a crucial first step, a spotlight on the challenges ahead.
And it's a stark reminder that the future of AI, while incredibly exciting, also demands a new level of responsibility and vigilance. This episode has certainly given me a lot to think about. What about you? What stands out to you as the most crucial aspect of of this research?
For me, it's the emphasis on on collaboration. This isn't a problem that that any one person or organization can solve on their own. We need a collective effort. Bringing together diverse perspectives and expertise to develop comprehensive solutions that can keep pace with with the rapidly evolving world of AI.
It's about recognizing that AI security is a shared responsibility, and we all have a role to play in shaping a safer and more secure future.
Well said.
Now, before we wrap things up, I want to shift gears a bit and talk about some of the practical implications of this research. Specifically, what can developers and users do right now to protect themselves from from TPIA and other emerging AI threats?
Well, one of the most important things is to be aware of the potential risks, understand how these attacks work, what the what the vulnerabilities are, and how to identify suspicious activity. Knowledge is power, and the more informed you are, the better equipped you'll be to make smart decisions.
So it's about staying informed, being proactive, and not just assuming that everything is secure by default.
Exactly. Don't rely solely on your AI coding assistant to to handle all the security for you. Be critical of the code you're using, especially when it comes from from external sources. Scrutinize those open source libraries. Look for look for potential red flags, and consider using code provenance tools to track the origin and history of the code you're integrating into your projects.
So it's about doing your due diligence, being cautious, and not blindly trusting every piece of code that comes your way.
Precisely, and don't underestimate the power of community. Engage with other developers. Share your experiences and learn from each other's mistakes. The cybersecurity community, it's a vast resource, and there's a lot of collective knowledge and expertise that can help us navigate these challenges.
It's about recognizing that we're all in this together,
Hmm.
and we can learn and grow from each other's experiences. Now, as we wrap up this deep dive into the world of TPIA and AI security, I want to leave our listeners with a final thought-provoking question. If TPIA can manipulate code with such stealth and precision, what other forms of AI generated content might be vulnerable to similar attacks?
That's an excellent question, and it's one that that researchers are actively exploring as AI models become more sophisticated and capable of generating increasingly complex outputs from text and images to music and even video. Well, we need to be prepared for a new wave of security challenges.
It's almost like we're standing at the edge of of a vast uncharted territory
Yeah.
with both incredible opportunities and unforeseen risks lurking around every corner.
Exactly. The future of AI is it's full of promise, but it's crucial that we approach it with a balanced perspective, recognizing both the potential benefits and the potential pitfalls. And as we move forward, we need to be prepared to adapt our our thinking, our tools, and our strategies to ensure that AI remains a force for good in the world.
Yeah, it really is. It's a fascinating thought and kind of unsettling too. That we might just be scratching the surface when it comes to AI's vulnerabilities as we become more and more reliant on AI generated content in all these different aspects of our lives. Well, we need to be prepared for the unexpected.
I agree. Absolutely. TPIA, it really serves as a powerful reminder, that AI security, it's not just about protecting code. It's about protecting the integrity of information, creative outputs, even decision-making processes that are increasingly influenced by AI.
So we're not just talking about like, cybersecurity in the traditional sense. We're talking uh, about safeguarding the very fabric of our, digital world as it becomes more, more intertwined with AI.
Exactly. And that requires a real shift in mindset, not just for security professionals, but for everyone who interacts with AI, from developers to end users. We need to cultivate a culture of awareness, skepticism, and responsibility when it comes to AI.
It's about understanding that AI is a powerful tool, but like any tool, it can be misused, or manipulated. We need to you need to be mindful of its limitations, its potential biases, and the ways in which it can be exploited.
And it's not just about being cautious. It's also about embracing the positive potential of AI. By understanding the risks, well, we can better mitigate them and ensure that AI continues to be a force for good in the world.
So it's about finding that balance between harnessing the power of AI and safeguarding against its potential pitfalls. Well, this has been an incredibly insightful deep dive, and I think our listeners now have a much deeper understanding of the complexities of AI security. As we wrap things up, what's the one key message that you want to leave our listeners with? What's the most important takeaway from this exploration of of TPIA and the broader landscape of AI security?
Well, I think the most important message here is this: the future of AI. It's bright, but it's not it's not without its challenges. TPIA, it's just one example of the types of threats we need to be prepared for. As AI continues to evolve, so too will the methods used to exploit it. The key is to remain vigilant, to stay informed, and to never underestimate the ingenuity of those seeking to undermine these powerful technologies.
It's a call to action then, a reminder that AI security is it's an ongoing process. It's a journey rather than a destination. We need to be constantly learning, adapting, and evolving our strategies to ensure that AI remains a force for progress and innovation rather than a source of vulnerability and risk. And on that note, I want to thank you for joining us on this deep dive into the world of AI security. We hope you found it informative, thought provoking, and maybe even a little bit unsettling. But as as we discussed, understanding the risks, well, it's the first step toward mitigating them. So stay curious, stay vigilant, and join us next time as we continue to explore the fascinating and ever evolving landscape of artificial intelligence.